Hi everyone, it's your favorite luminary with another video. Have you ever wondered where our humble planet ranks in terms of size compared to all of the other astronomical bodies that have formed since the Big Bang? Well, we're going to take a look at the big and small of things you'd find if you could travel through the universe. I think you'll be surprised at how big we are, yet how small we are in this hierarchy. Now, it helps if we define things. According to Oxford Languages, the word hierarchy is defined as an arrangement or classification of things according to relative importance or inclusiveness. So in this case, we'll arrange a universal hierarchy according to size. Although we can't list everything in space, as that would just take too much time, and truth be told, there's probably a lot left to discover, we're going to try to hit the high points. Let's start with objects we might find in our own solar system. First up, we have micrometeoroids. These are generously called tiny particles of space rocks, but they're so small that really they're glorified space dust. They're so small that if a micrometeoroid hit Earth, it would not burn up on entry. It would probably just float gently down to the surface. They usually weigh in at less than 1 gram and don't stand much of a chance against a Hoover. Next, we remove the micro and we just have meteoroids. These are actual space rocks that can range in size from a grain of sand to about 3 feet wide. A meteoroid that enters Earth's atmosphere is called a meteor and is the source of most of the shooting stars we see in the sky. If any part of the meteor survives the atmospheric burn and lands on Earth, it is called a meteorite. So we have 3 words to describe essentially the same thing, just in different location. A meteoroid impacting the Earth can cause minor damage or can potentially be dangerous if it lands in just the right place, but typically it won't cause catastrophic damage. The same cannot be said for the next item on our list, asteroids. Most asteroids are found in the asteroid belt between Mars and Jupiter. These can be up to 1,000 kilometers or just over 620 miles across. A smaller asteroid can cause some damage if it collides with Earth, but larger ones can make for a very bad day for any living organism. Just ask the dinosaurs. After asteroids, we have moons. A moon is defined as a natural satellite of a planet. Not all planets have moons. Mercury and Venus have no moons. Our own Earth only has one. Mars has two, and the gas giants each have many moons. Saturn has a total of 146 known moons, and that seems to be the record for our solar system. These gas giants are so massive and so far away, though, that it's a good bet that there are more out there waiting to be discovered. Moons can range anywhere from a couple of kilometers across to the largest, Ganymede, which is 5,268 kilometers across. Now, this is where our hierarchy gets a little murky. Technically, planets are next in order of increasing size, but there are 2 moons in our solar system, the aforementioned Ganymede and Titan, which are larger than the planet Mercury. I did say that planets are next on the list, but I'd be remiss if I didn't mention dwarf planets first. This portion of the video is dedicated to the memory of the planet Pluto, which in 2006 was reclassified as a dwarf planet. That year, the International Astronomical Union changed the working definition of a planet. They agreed on 3 criteria. 1. It must orbit around the Sun. 2. It must have enough mass to draw itself into a round shape. And 3. It must have cleared all other celestial bodies except its own moon from its orbit. Based on that third part of the definition, Pluto lost its planetary status, as it is one of the many objects in what is known as the Kuiper Belt. There are 5 known dwarf planets in our solar system, but astronomers speculate that there are many more. The 5 known dwarf planets are, as of right now, the largest Pluto, with a diameter of 2,380 kilometers, Eris, with a diameter of 2,330 kilometers, Haumea, with a diameter of 1,632 kilometers, Makemake at 1,440 kilometers, and the smallest Ceres, which is just under 1,000 kilometers. The planets in our solar system start at slightly larger sizes than the dwarf planets. There are 2 broad categories of planets in our solar system. the interior rocky, or sometimes called the terrestrial planets, and the Jovian or gas giants. The four closest planets to the Sun are the rocky planets, and they're quite small in comparison to their gas giant cousins. The smallest of the rocky planets is Mercury, with a diameter of just over 4,800 kilometers. And the largest is our own Earth, with a diameter of 13,000 kilometers, or just about. The gas giants, by comparison, range in size from Neptune, with a diameter of almost 50,000 kilometers, to Jupiter, with a diameter of over 140,000 kilometers. The final entry in our solar system is its most massive object, the Sun. How massive, you ask? With a diameter of 1.39 million kilometers, it's massive enough to swallow over 1 million Earths. As far as stars go, the Sun is considered an average-sized star. The biggest known star is the hypergiant UY Scuti, with a radius 1,700 times that of our Sun. So now we ask, is there anything bigger in our solar system than the Sun? The answer is sort of, but not really. Technically, comets, which are icy bodies that sometimes come from the outer solar system to the inner region near to the Sun, sprout tails as they heat up. The solid part of the comet, the nucleus, is usually less than 50 kilometers across. However, the gaseous coma can be as big as the Sun, at 1.5 million kilometers wide, and the tail can be incredibly long at hundreds of millions of kilometers. The reason we don't include these as larger than the Sun is because even though the length of comets can reach astounding proportions, they are relatively low in mass considering the coma and tails are gaseous. Now, if we want to go bigger, we have to leave the confines of our solar system. Black holes can range in size from microscopic to billions of kilometers wide. A black hole is an astronomical object with a gravitational pull so strong that nothing, not even light, can escape it. A black hole's surface, called its event horizon, defines the boundary where the velocity needed to escape exceeds the speed of light, which, as we know, is the cosmic speed limit, so nothing can go that fast. We can estimate the radius of a black hole by measuring the accretion disk. That's a ring of surrounding matter that's falling into the black hole, and the event horizon, the point of no return for that matter falling in. Astronomers have found black holes that have disks many times the size of our solar system. After black holes, we have nebulae. This is actually a giant cloud of dust and gas in space, but the word giant somewhat understates their size. They can range in size from our solar system to hundreds of light years across. Next up, we have star clusters, and these are groups of stars that are gravitationally bound to one another. They can be made up of hundreds, thousands, or even millions of stars. They're like small galaxies, and some cosmologists actually think that they could be remnants of galaxies after some catastrophic event. Star clusters range from about 10 to 30 light years across. Since star clusters are smaller than galaxies, then galaxies must be next on the list. The smallest known galaxies, called dwarf galaxies, are about 200 light years wide. Our own Milky Way galaxy is about 100,000 light years wide, and the largest known galaxy, IC 1101, is a mind-boggling 4 million light years wide. And finally, the largest known structures in the universe, superclusters. Galaxies are arranged in clusters that are typically several million light years wide, which in turn may be part of larger superclusters that could end up being several billion light years across. Now that does it for this list, but keep in mind that this is just a rule of thumb. There are exceptions all over the universe to this size order. But with that, hopefully now you have some understanding of how different objects in the universe stack up to one another in terms of their size. If you learned something or like this video, please help us out by liking, commenting, sharing, and subscribing. This really helps the channel grow. Thanks so much, and see you next time.